Maths is awesome, maths is fun, maths is there for everyone. Welcome back to the second lesson in Chapter 7, Parallel Lines. So again, it's a little bit like last class. Most of the work you've seen before in Year 8. We're going to have a look now at parallel lines. First of all, we need to understand three different terms. Well, when we have parallel lines, we mark down two lines with arrows on them to show that they are parallel. That means that they are always a constant distance apart, they will never meet. This line going through the parallel lines, and it doesn't matter what angle it goes, it could go at any angle at all, as long as it passes through the parallel lines, it is called a transversal. And we'll talk more about that term later, but what we have is two parallel lines, 1, 2, and a transversal. Now we're trying to spot alternate angles. Now I call alternate angles a Z shape, but that's not the technical term. You have to know that they are alternate angles. So if you look inside, or if you look at your diagram, can you see a Z type of shape being created there? Well, if you can, then the two angles that are created with the Z, they're equal to each other. Now alternately, I could actually have the Z going backwards, which means those two angles are equal to each other. So whenever you have parallel lines with a transversal, there are always pairs of alternate angles that are equal. They are identical. If you know one, you know the other. Let's talk now about corresponding angles. Now we call these F shape, but corresponding is the term that you need to spot. Can you see an F shape there? Well, underneath the arms, if I call them the arms, or the bits that stick out on the F, those two angles are the same as each other. They are equal. However, the F may not be a forwards F, it could be a backwards F. Or could be upside down. And it could be upside down in the other way. So when you're looking for corresponding angles, there's actually 4 different pairs of angles that you could find with corresponding angles whenever you have two parallel lines and a transversal. Our last one is the trickiest one. It's the co-interior angles. We go for C shape, and if you see a C shape there, we've got two angles inside. They are not equal. Co-interior angles add to give 180 degrees. So this angle which I've called A and this angle which I've called B have to add to give 180. Now, it could have also been that the C shape, if you like, was backwards, not to the right, it goes to the left. Well, they've still got two angles there. Now, probably should not have used A and B because when I look at this angle here, it's not the same as this angle here, and this angle is not the same as that angle, but those two angles add to give 180. So you need to understand that with your C shape, your co-interior angles, you get two angles that add to give 180. So here's our first example. Find the value, so find what x is in this case, and give reasons. Well, if you look at this, I can see a Z shape there. I'll even highlight it, which means x equals 55. So that's the answer, but I have to give a reason. Why are they equal? They're equal because they are alternate angles, because there was a Z shape. Let's go to part B. I've got two parallel lines and a transversal. There's my two bits that I know. What shape would that be and what type? Well, I can see an F shape there, which means x and 115 are equal. What's the reason they are equal? Well, if there's an F shape, they are corresponding. So we've got corresponding angles for this one. Part C, I've now got a slightly different scenario. I've got a C shape there, which means my two angles have to plus together to give 180. Why is that true? Because those angles are co-interior. That's the working out, or the beginning, the algebra part that'll lead to the working out to give me my answer. That's the reason. You have to give reasons. That's worth marks, putting that bracket there. Minus 62 to both sides. X is 118 degrees for this example. Part D. Now I've got to find the value of x and the value of y. Now, if I look at this, there are no F shapes, Z shapes, C shapes that link 117 to x or y. Now, there's many, many different ways I could do this. Here is one way. I could say I'm going to reposition x and y by putting them down with their corresponding or their matching angles. So if I look at the F shape here, that angle there and that angle there are the same. So that's x, that's also x because they're corresponding. If I look here, I'll draw it in a different colour. There's my backward F, which means that angle and that angle are corresponding angles as well. So they're the same. So I've able to put x there and y there because I've repositioned them due to the corresponding angles. That's important. I've got to explain that. Now that I'm looking here, I can see y and 117 are opposite to each other. So y equals 117. What's the reason they're equal to each other? If they're opposite, it's called vertically opposite. How can I find x? Well, I can see that there's a straight line going down there. Those two angles are on one side of the straight line, so those two angles add up to 180. So what's the reason that x plus 17 equals 180? Because angles on a line equal 180, and they are angles on one side of a line. Minus 117 to both sides, 180 minus 117 is 63 degrees. So I now know y, I know x, I've given reasons for everything, finished. Now, this example is by far the trickiest example of all the ones that we've put here, because my transversal is actually not a transversal. A parallel line, I've got a pair of parallel lines, but I don't have a straight line going through it. I have well, really it's like two lines being connected here at point X. Now again, there are several ways I can do this. I'm going to do this one of the several ways. I'm not going to show you all of the ways, but the way I do it is I look at this point here where the X is and I go, you know what, I'm going to draw in another parallel line. Now what I should do on that parallel line is I should put an arrowhead to show that all three lines are now parallel. If all three lines are parallel, how do I know that that's 55 degrees? Well, can you see a Z shape? So that's 55. If I look at this angle here, can you see a backward Z shape? So that angle there will be 60 degrees. So X is going to be those two angles added up. 55 plus 60 is 115. But where are my reasons? Well, I'm going to shortcut this a bit. I'm going to say alternate angles, and I'm going to do this. So 55 and 55 are the same because they're alternate. 60 and 60 are the same because they're alternate. How do I know x equals 55 plus 60? I can see that on the diagram. That is my working out for the reasons, and I'll accept that at this stage. Well, time for you to do some questions. Enjoy the experience as you always do. Bye for now.